Today, we are going to be talking about a hands-on guide for building cost-efficient CDC pipelines. And with us, we have our speaker, VP of Solutions Engineering, who is Sid Lasley. He has an experience of over 20 years in the same data space. So, Sid, over to you. And I think, yep.
Wonderful. Thank you, Radhika. It's exciting for you to join us today in this learning lab. My name is Sid Lasley. I was kidding with Radhika. I can't decide if my AI photo should be used for everything other than my real photo, but thanks for joining us. We're doing a hands-on lab today. We're going to talk about how you can build cost-effective CDC pipelines, and we'll talk a little bit about that in detail. Let me talk about our agenda for a moment. First, I want to introduce you to the concept of CDC pipelines. Really, how does it work? What's going on in the background? Then we'll talk a little bit about what is the benefit of CDC over a batch replication strategy. We'll talk a little bit about some of the challenges of building your own or a traditional approach to change data capture, which is CDC. And we'll talk about how Hevo approaches CDC. We have multiple approaches. We'll talk about how we automate it and make it very simple for you to manage change data capture in your environment. So with that said, we'll go forward. We will be capturing questions throughout the webinar, and we'll be happy to answer those questions when we conclude the demo today. So first, let's talk about CDC pipelines and kind of get an understanding of how they work. What you're seeing is a really high-level abstraction of databases. Databases often have a logging structure that are associated with them. It's something that captures whatever has happened in the database transactionally, events. An inserted record is captured, an updated record is captured, a deleted record is captured. CDC is the facility of leveraging that information that's captured in logs and being able to translate that into information that can be stored in a downstream analytical system. And often that type of functionality will provide you near real-time access to data in your business environment. Now, when you're building a CDC pipeline, and if you were building this from scratch, say you were writing some code to do it, you got to consider a number of things. You got to consider the complexity of the setup. And how hard would it be to maintain that piece of code or application once it's built? You've got to understand how to manage your performance bottlenecks and make sure that it's an efficient process. You've got to account for scalability. As my data volume grows, will I be able to scale this application, this piece of code, so that as that data volume grows, I can meet those expectations. I can meet SLAs or whatever may be defined for the downstream systems. One of the most critical areas is ensuring that the data is consistent, that you're not, corrupting the data or perhaps dropping the data and there's missing data. You're making business decisions on incorrect information. Now, let's talk a little bit about the benefits of using change data capture replication. One of the things that's the most powerful benefit is real-time information. Having information at your fingertips to make business decisions in near real time in a competitive environment. If you're looking at refreshed near real-time data and making a business decision, that is so much more impactful than looking at something that was refreshed 24 hours ago or last week. On top of that, because you're doing CDC, the recovery is much simpler. You can do a refresh much simpler and much more easily. And additionally, you're also going to minimize your operational costs and some of the impact on your database. So if you're running a lot of queries against an operational database, you're putting more load on that database above and beyond what the application is doing itself by leveraging the logging structure that's underneath the covers of that database. You're able to offload that operational cost and minimize that cost as part of this overall architecture. Now, when we talk about automating CDC pipelines with Hevo, we really remove all of that complexity I just described for you. We try to make it very much a set it and forget it environment. Again, we're going to enable those faster decisions with the pipelines that we build. We're going to minimize the disruption to any production workloads. We're going to take that workload away from the database and leverage the underpinnings of the logging. And again, help you with the operational costs associated with manual tasks, development, maintenance, all those things. Those things traditionally just go away when you leverage CDC with a pipeline and Hevo data. Now, there's some ways you can approach change data capture. You could look at timestamps in your database. Some databases may be set up where, as a record is updated, inserted, you will get a timestamp. And what you're then able to do is run a SQL statement where you're filtering records on a time date stamp. You can also use a snapshot in time. What does the database look at this very moment? Take that information and replicate it to a target system. Inside the database itself, you could introduce triggers. An event occurs, a record is updated, a record is deleted, and a trigger could trigger some downstream process. Or as we're talking about today, you can leverage the logging structures that are part of databases today. Now, we've helped a lot of organizations with their challenges around change data capture and managing large data in their environment. Deliver is basically an e-commerce fulfillment organization, for organizations like eBay, Amazon, Walmart, Shopify. You can just imagine the data volumes that they have. And they came to us with a challenge, and that was to help them manage their data volumes and really reduce the efforts they have. They had MySQL as a backend database, and they're trying to replicate a lot of information, a significant volume of information to Snowflake. Now, the gentleman, Emmett Murphy, who evaluated Hevo, selected Hevo because we have automated pipelines and a very easy to use platform that makes managing and scaling that data volume so much simpler. Now let's just look at some of the benefits that they received. A 10% productivity increase across their data engineering team. The team was much more efficient. They could focus on higher value tasks. In essence, we saved them 80 hours per month. That's 2 man weeks. Imagine if your team had 80 extra hours to work on projects to accomplish high value tasks. As part of what Deliver achieved in implementing Hevo, they saved those 80 hours, and they're actually able to manage 2x the data load capacity that they were previously able to manage when they were doing things manually. So they saw significant benefits using Hevo's CDC pipelines. Now, with that said, I'd like to exit out and show you a quick demo. So I'm going to switch over to Hevo real quickly. You're looking at Hevo data. We are a cloud platform. We are a cloud data integration platform. And what you're seeing in front of you right now are a series of pipelines. Hevo offers over 150 connectors to allow you to connect to applications, databases. As you can see, I've got several databases running in the background. I'm connected to a REST API. I've got Stripe as one of my sources, and here's an example of running a Salesforce pipeline, which you can also perform change data capture. For today's demo, I'm going to show you what it's like to create a Postgres to Snowflake pipeline. And first, to do that, I simply need to create a pipeline. Now, in this first step of this very simple 4-step wizard, I simply need to come in here and select the particular connector I need to configure for this exercise. So in this case, I'm going to connect to an Amazon RDS Postgres SQL connector that we have pre-built to make this as simple as possible. Now, I'm going to pick a pre-built one for you so you don't have to sit here and watch me type and mistype. And then I'm going to talk through a little bit. You know, host name, database port, user password, those are all standard fare. But let's talk about ingestion modes. Again, we talked about there are different ways in which you can accomplish change data capture. Our recommended approach is logical replication. For Postgres, we're going to leverage the WAL files, the write-ahead logs that will contain all the transactions that have occurred in the database. So as we run this pipeline, what we're going to do is perform a historical load. And what that will do is take whatever data is in the source database, replicate it to the target, and once that's completed, we will switch to this logical replication mode. That means we will incrementally update the target system with whatever changes have occurred in the source. So if an inserted record occurs, we'll capture that, an updated record. And here's the key thing, deleted records. If you're not using logical replication, being able to do something around deletions is very difficult because in essence, the database has deleted the record, it no longer exists, and your downstream application won't become aware of it. But with logical replication, we actually capture that log record that shows a deleted record, and we can then move that through the target and maybe do a soft delete so the record stays in place, but it's marked as deleted. Some other ways that we can ingest data, we can read from the table directly with a simple select statement, or you can write a custom SQL statement. So without all that said, let me move forward to the next step in our wizard. So right now we're testing the connectivity. We're testing Sid's ability to type a password. And look at that, I passed that test. Right now I'm looking at the schema of the particular database that I want to connect to. What I'm going to do is pull back the objects that are part of that database. And then I can simply select those objects as part of this pipeline process. So in this case, I'd like to select all the objects. So in that simple process, the first two steps of this wizard is complete. Now at this point, I'm going to configure a destination. What that means is, where would I like to write the change stream? Where would I like to replicate the source system to what target system? In this case, I've got Snowflake and Postgres destinations, but we support a lot more than that. These are the two that I've defined. In this case, I want to write to a Snowflake destination. Now, a couple of things here that are pretty powerful. One, we can define a naming standard. So I could define a naming standard for this. You know, if I wanted to, I could say, this came from my webinar. What will happen when the replication occurs is my tables will all be prepended or prefixed with webinar and the underscore character. And then if I want to find the tables that are associated with this replication, I know that naming standard. The next thing that we'll look at is what we call our auto mapping feature, an incredibly powerful feature. This is where the set it and forget it part comes into play. What we will do in this replication pipeline is we will discern the source schema. What does it look like? What are the field names? What are the data types? And we will create the equivalent structure in the target. In this case is Snowflake. So for every table that we source from, we'll create a destination table that looks just like that table, except we'll prepend it with webinar. Now, as that schema changes on the source, the power behind the auto mapping feature is we will move and manage that for you. If a column is added, if a column is deleted, if a column name is changed, we will update the downstream, the destination schema automatically for you. Now you see it's a toggle, that's an option. It's not mandatory. It's just there because most of our customers find this incredibly powerful and convenient for them to be able to almost not worry about the pipelines running in the background. Now, the final thing that I need to select before I complete my pipeline is what frequency in which I want to run this. You know, we talked about batch, we talked about change data capture. I can set this up to be streaming. Hevo's architecture is designed for streaming. Our underlying architecture is Kafka. So we're naturally designed for these near real-time streaming use cases. So I could set this up for streaming, and this would run in near real time, capturing the changes and applying them to Snowflake. Now I've got one of these pipelines running, so much like a cooking show, I'm going to pull one out of the oven and show you what it looks like while it's running. So let's dive into the exact same pipeline that I was just showing you. This is now what that pipeline would look like while running. So I don't have a significant amount of data, but the pipeline has processed 1,400 records across my several tables that are in that schema. You can see we've ingested, we've transformed, we've mapped that schema as I described to you in our auto mapping feature. and we have loaded that information into the Snowflake destination. Now, another powerful feature of Hevo is that we can dial the source and target at different frequencies. You could have your ingestion occurring very frequently and your loads occurring at a different frequency. Because of our logical architecture built on Kafka, we have the luxury of doing that. And on top of that, if I simply wanted to add more resources to this, I can simply add more resources with a click of the button. Our architecture supports the ability to granularly apply additional resources to any individual pipeline, so that if you have a pipeline that needs a particular SLA met, you're easily able to do that in Hevo because we can fine-tune the resources we put on each pipeline. A few more things I'd like to introduce to you as part of this pipeline. One of the powerful features, one of the many powerful features of Hevo is that we can act as what is known as an ELT tool or platform, an extraction, load, and transform platform. Or you can switch the L and the T, and we can become an ETL platform, an extraction, transform, and load platform. And we do that in a couple of ways. We allow you to introduce Python in the process of managing your pipeline. You can add a piece of Python code that will simply come in and do some sort of alteration to the table. It will change some data. It can add a new field. In this example, I want to get a sample record from my source. So you're seeing in JSON format my source. I have a piece of Python here. It's simply going to add a new field to my event. So I'm basically adding an additional field to the downstream destination. And I can test my Python in real time. And I can see that it did, in fact, add a new field. And I've put a static value to it, just to give it as an example. Now, say you don't like writing things in Python. We also have this wonderful drag and drop interface that will allow you to perform transformations through simple drag and drop transformation objects. And as you can see, we have quite a few of them over here. You can alter fields, you can change case, you can rename fields. In my example, I've got an if-then-else structure. If this particular event occurs, then I want to mask these fields. We have a masking function. So we give you a lot of flexibility to decide the exact architectural approach, whether you post-load and perform transformations, or before you load, you perform the transformations. Now, I mentioned to you the schema mapper, another powerful feature of Hevo. Right now, I'm benefiting from the fact that I have auto mapping enabled, and we will automatically adjust the target schema when the source schema changes. For any reason I wanted to come in here and change this, I could simply edit the mapping, and I can override that. I could actually select to auto map some of my tables, but maybe there's some tables I don't want to auto map. Maybe there's a downstream process I want to manage carefully. You can do that as well. And then one of my favorite aspects of Hevo is our wonderful support organization. When you look in the left-hand corner of our interface, you're seeing a live person. We have live support, 24/7 support. If I had an issue, if something didn't look correct, within about a minute and a half, I'd be online chatting with a support person. So it provides you that comfort in knowing that when you're setting up change data capture and you're doing this with critical business data, should you encounter any sort of problem, you'd be able to get access to support in a very timely basis. And a couple other things I'd like to talk you through while we're in this demo. We also allow you to do modeling. So we described to you that you could do ELT or ETL. So if you wanted to do something post-load in an ELT model, you can come in here and you can come in and model against your live Snowflake environment. I can run this table, I can create tables, I can schedule these post-load, and these would all be available to me as part of the Hevo platform. And on top of that, I can actually integrate with dbt and invoke dbt models as part of the post-load process. So in this very simple yet powerful interface, you can do everything soup to nuts to set up your CDC pipelines, to monitor them, to get the support you need, and to model any of the data that you need post-load that process. And with that, that's my demo. We can switch back and we can talk about any questions you may have.
Sid, we have a few questions in the Q&A
Okay.
chat.
Wonderful. Let me get into that and see if I can see them. Could you help me out with those questions? I'm unable to see them, Radhika.
Sure. So the first question is, does Hevo data support Confluent Kafka as destination?
We do not support Confluent Kafka as a destination. We do support it as a source on our source side of the pipeline.
Cool. Then we have another question. Can we transform the data in the pipeline, including combining data from a couple of tables, create a new table, table/destination, destination table Kafka topic?
So we're still talking about Kafka. In a broader answer to the question, we don't perform the joins during the pipeline process. During the transformation, you can perform a lot of different transformations of the data itself. You can modify it, you can filter it, but the join process itself would be something that you'd want to perform post-load in either our modeling feature or within a DBT model. And then you can model whatever joins, whatever materialized views you may need from that point.
Got it. So we have another question. In this pipeline, do we first move data from source to Hevo data and then move from Hevo data to destination?
So when we talk about ingestion, we actually ingest the data into the Hevo platform, which is under the covers a Kafka architecture. And then we're able to do what I described earlier, which is basically dial up and dial down the frequency and ingestion and loading, because the Kafka will store that data temporarily. And then when the load frequency occurs, we will load that data. And then if any error occurs, we flush the Kafka queues or topics so that there's no issue. All of the data is encrypted both in flight and while in transit.
The next question is, does Hevo data support BigQuery as a destination?
Yes, we absolutely do support BigQuery as a destination. We support all of the major cloud data warehouses.
Got it. The next question is, what row width limit does Hevo have, particularly for PostgreSQL, JSON/JSONB source columns?
Could you repeat the question? I'm not sure I'm following it.
What row width limits does Hevo have, particularly for PostgreSQL JSON source columns?
I'm not sure I understand the question. I'm going to answer generically, but I'd be happy to follow up with whomever asked the question. But we can do several things with JSON fields. We do have a flattener in the transformation object. So it depends on what you want to do with the JSON. If you want it to become part of an individual table or be broken out into arrays or into other tables, we have options to do those things. But would be happy to follow up with specifics so that I can properly answer that question.
Great. Then we have another question which says, how does this integrate with Azure? Is it a part of the marketplace, and would there be egress/ingress costs?
So we do integrate with Azure. We do support sourcing and targeting Azure environments. There would be whatever typical ingress egress charges you have for pulling data in and out of those environments would apply if you're using us to pull or push data into those environments. It would be the same model that you're probably used to. The back end of Hevo is actually running on AWS and GCP, but we do integrate with sources and targets, destinations in Azure.
Then we have another question, which is, thanks for the answers. How would you compare pricing model of Hevo data with Fivetran?
Well, that's an interesting question. We are we are priced very well as compared to most of our competitors is the answer that I would give. A
And
very competitive price.
yep. And we can maybe follow up with Nitin to
Absolutely.
give more brief as well on this.
Mm-hmm.
I guess these were all the questions right now. Do we have any more questions? We'll wait for another minute or so.
Okay. Well, it's been my pleasure speaking with all of you. I hope you found it informative. It's a short webinar because it's so simple for us to set up CDC pipelines in Hevo that you can do them in minutes. You'll be very impressed if you give us a try.
Cool. I think that was about it. Thank you so much. Oh, we have one more.
Okay, wonderful.
Yes. What do we need to observe Hevo data availability and performance?
Most of the tooling you need to observe Hevo is provided by Hevo. So we're going to provide you monitoring. I didn't show you all the monitoring capabilities for monitoring in jobs and processes, but we do have monitoring that'll show you the historical loads, the incremental loads. We have a suite of APIs that can also be leveraged for a lot of different ways to manage the Hevo environment. Even the creation of a Hevo pipeline can be automated through our APIs. So a lot of ways to manage and monitor the environment.
Great. I think that is about it. Thank you everybody
Wonderful.
for joining in. Thank you so much, Sid, for the webinar. Any last thoughts,
Thanks,
Sid?
everyone. It was my pleasure. If you want to give Hevo a try, please go to our website and initiate a trial. Me and my team will get engaged. We'll make sure you have a flawless experience during your trial. And we really thank you for joining us today for this webinar.